ಇದು ಮಾಹಿತಿ ಖಜಾನೆ ವಾಹಿನಿ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿ
ಮಾಹಿತಿ ಖಜಾನೆ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿಗೆ ನನ್ನೆಲ್ಲ ಸಂಸಿಕ್ತರಿಗೂ ಆತ್ಮೀಯವಾದ ಸ್ವಾಗತ. ಇಂದು ನಾವು ಮತ್ತೊಂದು ಉಪಯುಕ್ತ ಮಾಹಿತಿಯೊಂದಿಗೆ ಬಂದಿದ್ದೇವೆ. ಈ ವಿಡಿಯೋ ನಿಮಗೇನಾದರೂ ಇಷ್ಟವಾದಲ್ಲಿ ಲೈಕ್, ಶೇರ್, ಕಾಮೆಂಟ್ ಮಾಡಿ ಹಾಗೂ ಇನ್ನು ಹೆಚ್ಚು ಉಪಯುಕ್ತ ಮಾಹಿತಿಯನ್ನು ನಮ್ಮ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿಯಿಂದ ಏನಾದರೂ ನಿರೀಕ್ಷಿಸುತ್ತಿದ್ದೀರಾ? ನಿರೀಕ್ಷಿಸಿದಲ್ಲಿ ಬೆಲ್ ಐಕಾನ್ ಅನ್ನು ಕ್ಲಿಕ್ ಮಾಡುವುದರ ಮೂಲಕ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ.
Mission and Science Instruments, Chandrayaan, One Perspective Introduction. Arup Roy Chaudhary, Instrument Scientist, Chandrayaan, One Head SCPD Seda, Space Applications Center ARC at SAT. ISRO. Gov in Moon, our closest celestial body, has aroused curiosity in our mind much more than any other objects in the sky. The most acceptable hypothesis on formation of Moon is the giant impact of a planetesimal, as large as Mars, with Earth that ejected enormous amount of material to form the Moon. Immediately afterwards, Moon went through stages of partial melting which formed a magma ocean, solidification of crust, delayed impacts of large number of interplanetary bodies which created impact basins on crust, and volcanism which resulted in filling of these basins. There are thus two distinct features on Moon: dark lowland or Maria, and the brighter highlands or Terry. The highlands represents the ancient lunar crust. The Mare region represents large basins formed by impact of very large objects and were later filled by magmas from deeper interior. Meteoroids, the largest being Copernicus and Tychos, via 85 to 90 kilometers, resulted in formation of lunar regolith, a layer of dust and rocky fragments 5-10 m thick on level areas. 1. Interest on Moon. The Moon and Earth were formed within few million years, 4 billion years ago. Being connected with origin of Earth, giant impact theory, it holds the key to the understanding of the origin and early history of Earth. The Moon is almost completely devoid of atmosphere, life and intrinsic magnetic field, which means the surface is in direct contact with interplanetary medium, meteoroids, solar wind, solar and galactic cosmic rays. Thus Moon can serve as a monitor of the solar activity in direct vicinity of Earth. Moon has abundant resources of hydrogen, hence possibility of water, nitrogen, carbon, helium and other solar wind gases trapped in its regolith. Earlier studies showed that Moon has a relative abundance of helium-3 compared to Earth. He-3 can be used as fusion element and thus considered as an important fuel for power generation in future. The other interest is the possible presence of water ice in permanently shadowed regions, craters in poles. The lunar ice is thought to have come from comets that collided with it. This raises the prospects of establishing self-sustaining lunar colony. Also interest on study of Moon is for landing sites, space observatory and future colonization. There are still gaps in the knowledge about Moon despite the popular belief that the Apollo and Luna missions of the 1960s and early 1970s had gathered all the information from Moon. There is a renewed interest internationally for the exploration of Moon. India decided to send a mission to Moon in view of the renewed international interest and considering that such a mission will provide the needed thrust to basic science and engineering research in the country. Thus Chandrayaan 1, which means Moon Vehicle in Sanskrit, thus became India's first planetary mission. The primary objectives of Chandrayaan 1 are 1. To expand scientific knowledge about the Moon. 2. To upgrade India's technological capability. 3. To provide challenging opportunities for planetary research to the younger generation of Indian scientists. 1. 2. Chandrayaan 1. The Chandrayaan 1 is India's first instrumented mission to Moon. The spacecraft is cube-shaped, approx 1.5 m side, weighing 1,380 kilograms at launch, including propellant mass, 820 kilograms, and accommodating 11 science payloads. The PSLV-XL, PSLV-C11, rocket was used to inject the 1,380 kilograms mass spacecraft into a 256 by 22,866 kilometers elliptical parking orbit, EPO, on 22 October 2008. The 440N liquid motor of the spacecraft was then used for injection into the Lunar Transfer Trajectory, LTT, and for Lunar Orbit Insertion, LOI. Chandrayaan-1 was finally placed in the 100 kilometers circular polar orbit around Moon on 12 November 2008. On 14 November the Moon Impact Probe, MIP, was released from Chandrayaan to impact on Moon. It became the first Indian object to touch lunar surface. Chandrayaan-1 3 PSLV C11 LOI EB Earth burn pound 1 pound lunar burn pound 2 pound 3 pound 4 EPO EB 1 EB 2 EB 3 EB 4 EB 5 Chandrayaan-1 spacecraft 3-axis stabilized, cube-shaped, approx 1.5 m side, minus 1,380 kilograms at launch, including propellant mass, 820 kilograms, single-sided solar array, generates 700 W of power during eclipse, powered by 36Ah Li-ion battery, recorder for payload data transmission in X-band, star sensor and miniaturized gyros for attitude references, Coarse analog sun sensor for sun search acquisition, accelerometers to estimate velocity change, telemetry, tracking and command, TTC, in S-band passive thermal control systems -0. 7M parabolic antenna with dual gimbal mechanism to track Earth PSLV, C11, the launcher 44. 4M weighing 316 tons at lift of 4 stages, solid and liquid propulsion alternately 6 strap-on motors augment the first stage thrust 1. 4. Chandrayaan-1 ground segment. The ground segment of Chandrayaan-1 performed the crucial task of receiving the signals sent by the spacecraft. It also transmitted the commands to be sent to the spacecraft during different phases of mission. Besides, it processes and safekeeps the scientific information sent by Chandrayaan-1. The ground segment of Chandrayaan-1 consists of Indian Deep Space Network, IDSN, the communication link with Chandrayaan Spacecraft Control Center, SCC, responsible for all spacecraft operations, Indian Space Science Data Center, ISSDC, initial payload data processing and custodian of science data. IDSN consists of 2 large parabolic antennas, one with 18 meters and the other 32 meters diameter. ISSDC IDSN SCC-1. 5. Chandrayaan-1 payloads. Chandrayaan-1 carried 11 science payloads to meet the science objective of the mission. 5 of these are indigenous ISRO payloads, 6 are from international communities, in response to ISRO's announcement of Opportunity, AO. 2 of these has ISRO's collaboration. Indian Instruments TMC Terrain Mapping Camera HYSI, Hyperspectral Imager LLRI, Lunar Laser Ranging Instrument HEX, High Energy X-ray Spectrometer MIP, Moon Impact Probe Bulgarian Instrument RADAM, Radiation Dose Monitor Experiment ESA Instruments SIR-2, Near Infrared Spectrometer C1XS, Chandrayaan-1 X-ray Spectrometer SARA, Sub-Kev Atom Reflecting Analyzer NASA Instruments M3, Moon Mineralogical Mapper Mini-SAR, Miniature Synthetic Aperture Radar Payload Placement on Chandrayaan-1 MIP RADAM. SIR, to SARA LLRI TMC M3 Mini SAR-6's HYSI hex. Chandrayaan-1 payload details TMC, stereoscopic camera for topographic mapping with high spatial and altitude sampling. HYSI, imager for mineralogical mapping in large number of bands with high spectral resolution in visible and near-infrared band. LLRI, laser altimeter with altitude resolution of and LT10M. Slope information in addition to range information. Hex, spectral study in X-ray region of 10 keV to 70 keV with spatial resolution of 33 kilometers. MIP impacted on Moon at the start of the mission. The impactor has 3 instruments viz. Moon Imaging System, Radar Altimeter and Mass Spectrometer. Radom characterize the radiation environment in near-lunar space. SARA Moon Imaging using low-energy neutral atoms as diagnostics in the energy range 10 eV to 3. 2 keV for studying interaction of solar wind on lunar surface, SIR-2, near point spectrometer C1XS, X-ray spectroscopy, for determination of the chemical composition of crust and mantle 1 keV to 10 keV. 6s also includes an X-ray solar monitor 1 to 20 keV. M3, imaging spectrometer, operating up to range for measuring solar reflected energy. Mini-SIR radar system can operate as an altimeter scatterometer, radiometer, and as a synthetic aperture radar imager. 1.7. TMC and HYSI instruments terrain mapping camera, TMC, and hyperspectral imager, HYSI, are the 2 Indian imaging payloads for Chandrayaan-1 which were developed at Space Applications Center. The TMC instrument is intended for the topographic mapping of the complete Moon. It is a panchromatic camera with stereoscopic imaging in 4, nadir and aft directions of the spacecraft movement. Such high sampled map of entire lunar surface is available for the first time and will help in better understanding of the evolution process and detailed study of regions of scientific interests. SWOT spatial sampling spectral band stereo imaging radiometric levels know of gains exposure settings data rate view Mbps operating temperature degrees C MTF 96 SNR at 1. 2 MW cm to ARAM at 14 MW cm to ASM terrain mapping camera 5M x 5M at 100 km 20 km panchromatic band 0. 5 to 0, 75 meters along track triplet, 4, nadir, aft, 40 96 for each 16. 286, serial, 2010 and GT, 15 and GT, 80 and GT, 306. 3 weight, kg, dimension, mm3, regulated power, W1. 8450 asterisk to 55 asterisk 362, Y asterisk P plus R, aft detector plane nadir for nadir swath, 20 kilometers $100 mirrors aft mirrors for detector plane. Normalized spectral response. The HYSI instrument imaged the lunar surface in 64 bands in the Vernier spectral range with 12-bit quantization. The data available is ATM spatial sampled with 20 kilometers swath coverage from 100 kilometers altitude. The high sampled spatial and spectral data from the instrument will help in improving the available information on mineral composition of Moon. Spatial sampling swath spectral range know of bands BW, NM, sampling interval, NM, radiometric levels gains exposure settings operating temperature, degree C, MTF, %. SNR at 0, 8 MW cm to SR at count 4000 hyperspectral imager 30 m x 30 m at 100 km, 20 km 421 to 964 nanometers 64 contiguous between 12, 3 to 20, 5, 8, 3 4096 to fourths numbers. 2010 and GT 20 and GT 100 and GT 1000 weight kg 2 5 electronics 178x 163x 194 RXPXY 172x 192x 65 regulated power W 0 8 dimension mm EOM-HYC Chandrayaan 1 spectral bands 40 kilometers. Swath 20 kilometers 030 to 0 1 OD1 9 wavelength nm.